Okay, here we are with the second of the cubic and quartic functions revision. The first question we have here is to solve the expression x take 2, x plus 3, x take 4, x plus 5. What we need to do with this is we can apply the null factor theorem, where if something is equal to 0, everything is multiplied together, then each of these terms could equal to 0. So what we do is we just treat each of these terms as if they're equal to 0. So we can go x minus 2 equals 0, x plus 3 equals 0 because it could, x take 4 equals 0 because it could, x plus 5 similarly could equal 0. And then we solve each one of those for x. So if x minus 2 equals 0, add 2 to both sides, then we have x will equal 2. For the second one, we have x plus 3 equals 0, so take away 3 from both sides, we have x will equal negative 3. X take 4 equals 0, add 4 to both sides, x will equal positive 4. And x plus 5 equals 0, take 5 from both sides, we'll have x equals negative 5. So the solutions to this is that x could equal negative 5, negative 3, 2, or 4. And that's that. Okay, on to the next question. If x take 3 is a factor of x squared plus ax plus b, then what does 3a plus b plus 10 equal? Okay, what we need to do with this one, we're told that x minus 3 is a factor, so if we set x minus 3 equal to 0, rearrange that, we get x is equal to positive 3, and we want to substitute that into this function. So the function that we have here, f of x is equal to x squared plus ax plus b, for a function of 3 will be equal to 3 squared plus a times 3 plus b, which can be simplified down to become 9 plus 3a plus b. Okay, so that's what that's equal to. The question is then asking us, if that's a factor, what does 3a plus b plus 10 equal to? We've got 3a plus b plus 9 is equal to 0. Okay, we should define that. That's all equal to 0 if it's a factor. So all of that's equal to 9. So if we're going to be plussing 10 instead of plussing 9, that'll tell us that the answer to our question will be 1. So 3a plus b plus 10 will equal 1, simply because it's 1 more than that. Okay, next question. Solve for x plus 2, 2x take 1, and x take 4. Again, we need to apply the null factor theorem, so each one of these brackets we set it equal to 0. So we can have x plus 2 equals 0. Rearrange that, we get take away 2 from both sides, x will equal negative 2. If we have 2x minus 1 is equal to 0, then we add 1 to both sides, which gives us 2x is equal to 1. Then divide both sides by 2. That will give us x is equal to a half. And for the third one, we have x minus 4 equals 0. What we do with that one is we add 4 to both sides. And that will give us x is equal to positive 4. So the solutions for this one is x can equal negative 2, a half, or 4. Okay, next question. Okay, this question, what is the equation of the image if y equals x cubed is transformed under a dilation factor of 4 from the y-axis, and then by a translation of 6 units in the positive direction of the x-axis? Now, for those of you who are using the Cambridge Essential Math Methods 1 and 2 CAS version, You can refer to page 174 of the text for a bit more explanation of this. If we're looking at a dilation factor of y, if we're looking at dilation factor of a from the y-axis, I'll just write this down. If we're looking at a dilation factor of a from the y-axis, then our function of y equals f of x is mapped to y is equal to a function of x over a. So that will give us a bit of a hint of what we need to do. So in applying that to this question, we've got y is equal to x cubed, or function of x is equal to x cubed. That's where we start with, but we have to apply this dilation by going x over a. We've got a factor of 4, so we need to be doing this as a function of x over 4, which will be equal to x over 4 cubed, which will equal x cubed over 4 cubed is 64. Okay, so that there is how we apply the dilation factor. And then what we need to do is apply the translation factor, which was shifting it. So a dilation is a stretching, a translation is a shifting. So in this case, we're shifting it 6 units in the positive direction of the x-axis. So that indicates we'll need to have a bracket associated with our x. So the image that we're looking at will be, and we'll write our x. If it's shifted in the positive direction of the y-axis, then we go x minus 6. If it was shifted in the negative direction of the x-axis, we go x plus 6 cubed, and then divided by 64. So the answer to the question is this function down the bottom here. So this bit here is dealing with the translation, or the shifting, and this bit here is dealing with the dilation, or the stretching. Okay, on to the next question. What are the x and y axis intercepts of y equals x plus a all squared, x squared minus b squared? Okay, in the sheet that I've handed out, it was only asking for the x-axis intercepts, but we'll find the x and y-axis intercepts. Okay, for the x-axis intercepts, what we need to do is fully factorise this. So we have y is equal to x plus a squared, x squared minus b squared. This second part here is a difference of 2 squares. So if we have a difference of 2 squares, where we have a squared minus b squared, that is equal to a minus b, a plus b. So in our case, we can rewrite this as x plus a all squared, x plus b, and x take away b. Okay. Now, when we're identifying this, when we have something squared, that sort of indicates where the graph will come down and touch the x-axis. So in that case there, it would actually touch the x-axis at negative a. set that bracket equal to 0, rearrange it, x will be equal to negative a. So we're talking about the graph touching at x is equal to negative a. The other two here are actually going to be intersections. Okay, the square, it's a touch, we haven't got squares there, so we're going to have an intersections there. So again with these, we set each of those brackets equal to 0, so we'll have for the second one, x will equal negative b, and for the third one, x will equal positive b. Okay, so our x-intercepts, so where it's touching or where it's crossing over, the answer to that will be at negative a, which is actually a touch, negative b, and positive b. Okay. Then if we're going to work out the y-intercept, I'll put that in here, for the y-intercept, if you remember, for the y-intercept, x is equal to 0, so that's the same thing for the x-intercept, y is equal to 0, so that's why we make the thing equal to 0 at the end and solve it that way. For the y-intercept, we have x equal to 0, so we take our same, I'll use the one at the very top, so y is equal to x plus a all squared, x squared minus b squared. And if we substitute x, then y will equal 0 plus a is just a squared, and 0 take away b squared is going to be negative b squared. So that will be negative a squared b squared. Okay, that's the answer to that. And if I keep looking at this little graph that I started to draw, how that all might come into play is that we could have another x-intercept of negative b. We'll have y-axis and positive b as another intersection. So the graph could come around somewhere like so. And we would have an intersection of negative a squared, b squared, whatever those values may be. Okay, thanks.